Hello guys, welcome to our mathematics lesson. Remember to subscribe to our channel. Right, what are we going to learn today? The angle at the center is equal to 2 times the angle at the circumference. We are going to prove this theorem. Do you know how to prove it? Okay, if you know it, it's going to be revision. It's going to be revision. Remember, this is an examinable theorem. It means you may find this theorem in the exams. Okay, right. We're saying the angle subtended by an arc at the center of a circle. What does it do? Remember that. Subtended means what? It means it is formed. It is formed by an arc. Right. Subtended means it is formed by an arc. So I have an arc here. You see the arc? Okay, right. So we're forming an angle. We're forming an angle at the center. So where this is the 2 points where the lines start, and then we're forming an angle at the center. You see that? Let me go back a bit. Right, we have an arc. Then the angle is formed at the center by the lines that start from the arc there. And then they are forming an angle at the center. Then this is the angle we're talking about. We're saying the angle is subtended by an arc at the center. The angle subtended by an arc at the center. What does it do? Do you remember that? I gave you when I introduced the lesson. We say the angle subtended by this arc. This is the arc. Okay? Angle is subtended by this arc. What does it do? It is double the size of the angle subtended by the same arc at the circumference. Okay, so we have the lines go back to the starting point there and then form the angle at the circumference. So we have two angles here, the one that is formed at the center and then the other one which is formed at the circumference. The one which is formed at the center is 2 times the angle formed at the circumference. Let me give you some questions. Let's say I have, this is 60 degrees. What will be this angle here? What will be this angle here? Let me write a question mark. What will be the angle there? Okay, if this one at the center is 60 degrees, what will be the angle at the circumference? It's going to be, it is 30 degrees, isn't it? Because it is subtended by the same arc at the circumference. Okay, right. You can even pause the video and ask yourself these questions. Right, what if this one is 25 degrees here? This angle is 25 degrees. What will be this angle here? It is going to be 50 degrees. You see that? Because it is the angle subtended at the center is 2 times the angle subtended at the circumference. Okay, don't forget that. Now, we need to prove this theorem. Learners, we need to prove this theorem. Do you know how we do it? Remember what you do with our lessons? You pause the video and try things, okay? And then when I give you the solutions, you mark your work. Right, so now we're going to prove the theorem. Let's just talk about the reason that is acceptable. Right, you can write in the examination, you can write angle at the center. This represents the angle. Angle at the center is 2 times, is equals to 2 times the angle at the circumference. This is an acceptable reason, okay? You can use that in the exams. Right, now, how do we prove? Remember, every proof, we start with the construction, okay? So we're going to construct here CO. You see, CO, right? We want to prove that angle AOB, this angle, is 2 times this angle. So we've constructed here CO and produced it to N. Produced it to N like that. Okay. So now after doing that, what do we do? What do we do, learners? You can try to pause the video and try this on your own. What do you think is the next step? Right. By constructing this line CN, we have created 2 triangles. Do you see the 2 triangles? Right. There's triangle. We name the angles first. Right, we have triangle ACO. Do you see triangle ACO? That's a triangle that we've created. We also created triangle BCO. You see that? Now, let's look at triangle ACO. You remember the properties of triangles? Okay. Or geometry of triangles. Do you remember that? Right. Angles in a triangle add up to 180 degrees. What else? The exterior angle of a triangle is equal to the sum of the opposite interior angles. You remember that, okay? And then for isosceles triangle, we say angles opposite equal sides are equal. Do you remember that? We're going to apply some of those. So now we have here, we're saying angle O1. Do you see angle O1, which is this one, is equals to angle C1 plus angle A. Why? Why is angle O1 equals to angle C1 plus angle A? Because angle O1 is an exterior angle of a triangle. It is an exterior angle of a triangle. Do you see that? Okay, right. Let me just show you. This is the angle we're talking about. This is the triangle we're talking about. So angle O1 is equals to angle C1 plus angle A. Okay, right. Now, what can you say about angle A and angle C1? Can you try to check there? What can you say about angle A and angle C1? This angle and this angle. What can you say about them? They are they are equal because remember OC and OA are radii. So these are sides which are equal. And remember angles opposite equal sides are what? Are equal. So angle A and angle C1 are equal. So it means here we can write angle C1 instead of saying angle A, isn't it? Okay, right, remember that. So now we can say, but angle C1 is equal to angle A because OA is equal to OC, they are radii, or we can say angles opposite equal sides, right? So now we can conclude and say angle O1 is equal to what? Angle 2 times C1. Okay, right. And then you write on our diagram, we write on our rider there, and then this is angle 2 times angle C1. Only O1 is 2 times angle C1. You see that? Okay, because we've replaced, let me just show you here. We said angle O1 is equals to angle C1 plus angle C1. Because we said angle A is equals to angle C1. So we can replace that with angle C1. Then this is 2 times angle C1. You see that? That's why we have this. Okay? Right. So we're done with the triangle ACO. I want you to try to do the same thing with triangle BCO. Okay? Try to pause the lesson and then you try on the triangle BCO. Okay, let's try. Right, welcome back. Learners, did you manage to do something? Let's see. Let's see. Let's look at triangle BCO. This is the triangle BCO. Okay. We have an exterior angle here. We have this one, isn't it? We have this one. You see that? It is equals to this angle C2 plus angle B, isn't it? And then again, we can easily see that angle B and angle C2 are equal because OC and OB are radii, they are equal. So these are angles opposite equal sides. Angle B and angle C2 are angles opposite equal sides. So we can use that to solve our problem here. Okay, right. Let's try to do it together now. So we're saying this is the triangle here. Angle O2 is equal to angle C2 plus B. We've talked about that. You see that? So angle O2 is equal to angle C2 plus angle B. Okay? Because it's an exterior angle of a triangle. Exterior angle of a triangle. Okay? But we are saying C2 is equal to B. We talked about that. You see? C2 is equal to B. Why? We're repeating the same thing. C2 is equal to B. Why? Because their angles opposite equal sides, or OB and OC are equal because they are radii. You see that? And then now, where there's B, we can write C2 here. Okay, so it's going to be O2 is equals to angle C2 plus angle C2. I've replaced B with angle C2 here. So meaning that angle O2 is equal to 2 times angle C2. Okay, you see that? Right. And then now we can write on our diagram here. So this is our angle O2, which is equal to angle 2 times. sorry, 2 times, which is equal to 2 times angle C2. Okay, right. Now, we wanted to prove what? We wanted to prove that this angle AOB is 2 times angle ACB. Okay, and you're almost done. Right, now you can see that this is angle O1 plus angle O2 is equal to 2 times angle C1 plus angle C2, isn't it? Okay, right. Angle O1, which is this angle, and plus this angle is equal to this plus this. And then here we can factor out 2. You see that? Okay, so AOB, this angle is 2 times angle C1 plus angle C2. And then what is angle C1 plus angle C2? This angle here. This is angle C1 plus angle C2, isn't it? So we can replace this C1 plus C2 by ACB, because this is angle ACB. This is angle ACB. You see that? ACB. You see that? So now we have proved that the angle at the center is 2 times the angle at the circumference. Okay, we've proved that the angle at the center is 2 times the angle at the circumference. Remember the reason we say angle at the center equals 2 times the angle at the circumference. Right. Okay, we're done with today's lesson, great learners. Let's hope we have learned something and you're going to remember how to prove this theorem. Let's meet in our next lesson. Goodbye.